the last one too. And I also can't guarantee that I'll be functional because it's nearly midnight for me. So what's the best way to close out HashiTalks build other than to write a bunch of Golang code at 11:40 p.m.? So let's hope that I can do this. All right. I'm going to share my screen. The first important thing to know is that we're going to play a game of bingo. I'm going to acknowledge I did not write the bingo card for a couple of reasons, because it would probably be weird if I I made my own bingo card for a couple of reasons. I mean, then it would be kind of cheating, I guess. You're not really supposed to create your own card and share it with yourself, knowing what you're going to say. So what I did was I asked our esteemed colleague, Rob, to play bingo. Yes, I know, Mo. I'm like, I don't know how we're going to do this, but we're going to try. I won't be watching the chat, so I'm going to drop the bingo card in there. I think Cole has the bingo card. Cole, if you could follow along, yes, if you could follow along with the talk and cross out anything that you are hearing me mention, please do. I cannot track it myself, yes, because I attempted to write my own bingo and it didn't really work. So we're going to just go with the bingo card. Okay. So today we're going to talk about building a Vault secrets engine. You heard a couple things about Vault secrets engines, Vault plugins today. What I wanted to do was break it down step by step, right? The Vault SDK, plugin SDK specifically, doesn't really have as much description as to what you're supposed to do and what are the important interfaces. So today, what I'm going to do is show you which interfaces are important and how I go about going through and developing a plugin from scratch. The example API we're going to use today is something called HashiCorp. You might have heard of it when you've developed a Terraform provider. You might have also heard of it if you've been working on some of the console demos and the console tutorials. The one thing I will tell you is that HashiCorp was poorly constructed in the authentication side. I had to make some extensions. What we're going to do is have a couple different API paths we're going to use today. There are a lot of API paths on HashiCorp. We're going to use 3 of them today. The first is sign up. You post request and you sign up a username and password. Now this issues a JOT, a JSON web token to you. You can use a JOT. It's perfectly fine. So that I would consider sort of like the root token. Then you also have sign in, which is a reissuance of a token. And then you have a sign out, which is the revocation of a token. So these are the 3 main ones we're going to be using. If you recall from the Terraform provider, because you're maybe used to Terraform provider development, this is where you're going to have the API interfaces and how you're going to interact with revocation. Now, if you're not familiar with secrets engines specifically in Vault, secrets engines in Vault rotate and revoke a token, or any secret for that matter. We're going to do a more simplistic API token. If you're using something like a database that's more complicated, I'm not going to go into that today. I don't have enough time for that, but if you are curious, you're more than welcome to ask me. All right, so the first thing we're going to do is go to code, because that's where we're going to start. The first place to always start when you code, people can debate on this. You can at me in the chat. I don't really know. You're going to go look at main.go. And what's interesting about a Vault secrets engine specifically, and a lot of the Vault authentication methods, they use the same structure on main.go. It is nested under a CMD / the Vault plugin name and main.go. The reason why it's nested this way is that when you build your plugin, you're identifying a separate main function, right? So this a separate main function that's kind of outside the bounds of all of your interfaces and everything you're going to need to build the secrets engine. So most secrets engines you'll find have the structure of CMD, Vault plugin secret, and then main.go. You don't have to change too much on main.go, actually. There are a couple dependencies you do need, right? And the main 2 are the Vault /API and the Vault /SDK /plugin. Those are the main dependencies that you will need for a Vault secrets engine. You'll also need to import the Vault plugin that you're using. In this case, I am targeting my API HashiCorp, so I'm going to import that as well. The other piece that you will need, and the next place to go, is to create a backend. You can put the backend declaration anywhere you want to, as long as you're comfortable with sort of the Golang package structure. But I put the backend at the top level because it's just easier. When you create a backend, there's a couple of important functions that you'll need, and some of them are pretty much static. You don't really change them, so you could copy and paste them out of here and paste them into your files at your own risk. The first is a factory. If you recall, some of the Terraform providers, most of the Terraform providers do this as well, but there's a factory interface, and this factory interface instantiates the backend for your secrets engine. Secrets engines have something called a backend. Basically, this is a storage interface for the secret to be stored into Vault. So that's why you have your interface. Okay, so we have the factory itself, and factory calls, as I mentioned, the backend. Most of the backends will have the same 3 attributes, which is the framework.backend, a lock. The lock is important for specifically when you write information to store that data for config or for the tokens. And you also have a client. In this case, this will be the client that goes to your target API. It helps if you have a Go client for your API. If you don't, you should probably write one just so that it's easier to interface with. The next important function is the backend function. This backend is where you're going to create your custom secrets engine backend. And a backend has a couple of different schemas in it. So you'll notice this is pretty similar to a lot of the other HashiCorp schemas that you'll notice. So there's the backend, framework backend. There's a couple of paths, and I think this is more unique to Vault. The way secrets engines work is that when you register a new plugin or a new secrets engine, it extends the Vault API. So what you're declaring here is that the backend extends the Vault API at certain paths. And some of these include these storage paths. So here I have a local storage path, and I'm declaring a framework write ahead log. I'm not going to go too much into write ahead log, but in most secrets engines, you probably won't need a write ahead log specific behavior. You can just leave it as framework.wall prefix. This is for Vault Replication, which is in Vault Enterprise. You also have some CL wrap storage. I'm not going to go into CL wrap, but the idea is when you do want to wrap some of these configurations as well as roles, you have the ability here. Now, there's a couple of other pieces here, which is paths. Paths is the extensions to the Vault Secrets Engine API. So this is something like roles. This is something like creds, if you're familiar with it. This is config. And you also have the secret. If you have multiple kinds of secrets, you need to add it to this object here. Otherwise, you can just add the one secret that you're planning. We're going to add one secret today because we're only doing tokens. But if you had something else, you would add it to the list of secrets. Backend type is type logical, and invalidate, we'll call a function for invalidate behavior. All right, so we're going to go through a couple more of these, and I'm just going to breeze through them. The comments, I try to include comments that describe a little bit of what they're doing. But most of these you're probably going to keep across your secrets engines, including reset and invalidate. Reset clears client configuration. So that way, if you change your client configuration, you don't have to worry about your client. Vault will handle that. And it also invalidates and clears the backend. In terms of the more important function that we're going to look at, the most important function likely, it is this get client. So it will retrieve the client and instantiate a new client. So this is where Vault itself will retrieve a configuration and pass it to your client. And that client is targeting the API. In this case, we have HashiCups. Okay, so we're going to go to the next file that you'll need. Don't worry, we'll update backend.go, but I had to remove some code before we could get anywhere with this. I'll show you client.go just because it's a little bit important to include this. In most plugins, you'll notice that people separate out a client interface and they create a struct for their specific target API client, right? So you want to wrap your API client in this particular structure just so that you abstract it. So any changes you make for your API client, you're able to reference it here without affecting the upstream dependencies from the Vault plugin. So here I have a couple things missing. I'm just going to copy paste and fill them in because originally I was going to type them out. But the important thing is that you'll notice that it's doing a couple checks for a config. config, in my case for HashiCorp, requires a username, password, and the URL. Those are the three main configs I'm going to be using. I just need to point the URL. I need to log in with username and a password. But what is missing here is that I never instantiate the client, because remember, I wrap this around the HashiCorp client. So what I'm going to do is, well, add code to instantiate the client. In this case, I had to update it myself, but I did have to create some new SDK, some new Golang SDK updates for HashiCorp specifically to do this. So here, I'm just going to instantiate a new client, and then if error is not nil, return error. The important thing to understand about this return is that it will surface the errors up through the plugin. So you basically want to make sure that if you are doing this, you're always surfacing your errors up, because it's very hard to debug what is going on when you are trying to figure out why your plugin's not loading or where the error is coming from. So helps to have errors surface up. So always just make sure that you're returning the error. So this interface very rarely changes. All right, so we have a new client and we're returning the abstraction for said client. Awesome. Okay, so the next important file that you'll need is path config. And I'll open path config for you. Path config contains the configuration you need to pass to Vault. So if you're familiar with Vault secrets engines, what you need to do is pass configuration to a secrets engine, and that secrets engine can then target your API, your database. So you need to define a config. Defining a config is pretty much just a repetition of the schema. So I took out a lot of the schema here and I'm just going to paste them in, but the path config is the main interface that you're going to be using to define the configuration path. So that's /config for your secrets engine. In this case, you have a couple of fields that are important. Your field schema is the one that's going to primarily define what you'll need to pass in. So in this case, remember, I need a config with the username, password, and URL. So I'm just going to pop that in there. And the other thing that you'll notice that's a little bit similar to if you are familiar with Terraform provider development as well, what's fairly similar is that there's actually some display attributes. So you can use these attributes to choose how you're either displaying the information, what kind of type it should be. Is it a more dynamic type? These are all strings. I am hiding the password because whenever someone is calling config, I don't think I want them getting the password because it could be a root password. So we're just going to leave it sensitive true. The other couple things that we have are operations. This is also fairly similar. We have, well, create, read, update, and delete operations. Create, read, update, and delete operations can map to any other kind of config, configs. And some of these configs might be reading it. In this case, we consolidate the create and update to path config write. I'm not going to go too deeply into deciding how you're going to consolidate some of these behaviors, but know that write is idempotent. So whatever I do in write, if the token is already created, write will account for that. If the token has not been created, write will account for that. So the idea behind all of these functions is that you need to make sure that the behavior of your API is captured in the logic of all of these functions. There's also an existence check, and existence checks makes sure that the configuration even exists in the first place. And there's some help synopsis and descriptions that you'll also need to consider as well. Okay. So path config read here, I'm not going to go too deeply into this, but the response will return a username URL. Notice I don't return the password. It is sensitive, so I don't want someone just compromising the password for some reason. The path config write is the more important one here. I'm going to retrieve the username and URL from data. Notice that it passes some data, field data through here. Anytime Vault has this path config write call, it will pass some data from the call itself. And that data should include the username and URL for the config. It also retrieves the password if you are passing in the password. The other important thing is that it puts it into an entry. So this request.storage is basically the storage API for Vault. It just puts it in there. There's put, I think there's get, there's read, etc. It's a whole API in itself. So you just have to make sure you add the entry as a config. And config delete is, well, storage delete. So you can imagine You notice there's a lot of repetition in this. Basically, we structured it around a lot of create, read, update, delete, and your API, if it follows that convention, should follow that. Okay. We're going to go to, actually, before I do this, I'm going to just unit test this to make sure it works because I filled in some things, right? If you are using VS Code and you do want to test and you want to try this out, there are unit tests. I have a launch.json included, and it will show you how you configure it. But basically, the unit tests themselves run a couple of different things. The unit tests, for example, will show fail, et cetera. But for the most part, some of them should show pass as well. So you'll know some of them has pause, continue, skip. But the unit tests, very similar to Terraform in some ways. It has a couple other pieces to it. There's a lot of mocks that you have to create. You have to, for example, create a test mock for your backend. You have to do a couple of other interesting things, like you have to test a token role list, you have to mock them out. You'll notice this t.run is very common as well. You'll have a test token create, you'll go through all of these functions. And so the result is that I'm not going to go too much into testing because it is not complicated, but it is a lot of repetition itself. If you do have direct questions, you're more than welcome to reach out to me. All right. Let's see. The next one that we have is path roles. So path roles is a Vault role. You've got Vault roles that you can define with permissions, or you can define them without permissions. So you have config and then you have role. I always make sure to point this out because you have config and then you have role and then you have the creds. So config first, then you set the role, and then you configure creds for the credentials for the role. So the role itself has a couple of schema. It's fairly similar schema change, a couple schema definitions that you do have to consider. For the role, the important thing to consider and to include, if I can pull this, is to add, create, read, update, and delete for the role. The roles themselves, it's dependent on your secrets that you're trying to rotate or revoke. Some of them will have permissions required that you could pass in and you can configure and then pass through. Some of them do not. So ultimately, it will depend on how you structure that. In the Terraform Cloud secrets engine, for example, there's like 3 different types of tokens, but they're all tokens at the end of the day. They're the same token. They're just different hierarchies. And so the result is that the role is the permission level. So that way you define things at the role level, and then the token gets issued depending on the type of role. So that's where this important thing is. The other thing that you want to set as part of the role is time to live. TTL, max TTL should always be in here. All right, I have one more thing. When you do a role, you also have a list operation. So you not only have the create, read, update, and delete, you also have a list operation. So here I have a regular expression to list any of the roles that I've created for the secrets engine. And what you'll recognize is a lot of this repeats once again. I think the really important one here is just to make sure that you are checking your TTL. This is where the role is where you're going to retrieve the time to live, and you're going to actually do the logical check of whether or not the time to live, which is when Vault should revoke the lease for that token, is greater than, has exceeded or is greater or less than the maximum that you've set. And then make sure you, of course, set the role. All right, we're going through this really fast, but I want to make sure we get through it. And I know we're getting late. So HashiCorp's token is the next piece. So after you've gotten the role, the next thing you need to do is create a structure for the secret, right? So remember, we went through config. Config is for secrets engine. Role is for permissions. Token or secret, right? That structure needs to be there first before you even start issuing or extending the credentials endpoint for the role. So with the secret, I created the HashiCorp's token structure, and this includes username, user ID, token. I don't need all of these fields. The really important one that I do need is a token. Now, I have a really bad API in that I don't have an API that tracks token ID. The revocation is actually dependent on the token itself. So bad API. You're not always going to have perfect APIs. And so some of these things you do have to edit and change. So what you're going to see in this code base is that there's actually not a great API behavior. It's actually doing revocation directly on the token and not a token ID that's getting referenced to an API. So just keeping that in mind. But the important thing is that not only do you have to declare a token or secret structure, you have to declare a sort of wrap around this like HashiCorp's token framework secret. You have to declare it as a secret. And then you do a token revoke and a token renew. The reason why you want to separately create a token renew and token revoke per secret or per secret type is that sometimes the revocation and the renewal behavior is different, right, for each type of secret. And Azure principal, when you revoke that credential, is going to be different than a JOT. So here, what I'm basically pulling out is this internal data. This is actually really nuanced in that internal data, you pass it between sort of Vault interfaces. You can't just access data. So I can't just get the token. I have to pass it as part of the internal data format. And this will allow me to delete the token. So this is just more code based about deleting the token. And renewal is a little bit more interesting. Renewal means that I re-sign or I retrieve the token and I recreate it. So that's where this is a little bit different as well. You'll notice that the response is here. So the revocation is where you're going to say, I'm going to delete the token. You don't do a delete. You don't implement a delete on credentials. You don't implement a delete on roles. You actually do it as part of token revoke. And that's what's a little bit different about a Vault secrets engine. You never implement a delete path. You embed the delete in the revocation. Okay, so let me make sure that this is actually filled in before I do this. Yes, it is filled in. Okay, great. Create token. Did I create? Let me just make sure. Okay. So create token, you'll notice it has the creation. This is the call to the client. Every function in Vault has the ability to access the client. So here I'm signing in, and remember, this gives me a new token. Delete token is, well, signing out. So there we go. All right. Last file is path credentials. Path credentials is actually a little bit more, it's not as complicated. It's pretty much the same set of schemas again, right? So what you're going to do is you're going to define a pattern and you're going to also define the fields that it's going to intake. So all I really need for this one is the name of the role. For most credentials, that's all you really need. It's the name of the role. You don't really need more of it. The read and the update operation are both the same. They're going to use the read. Again, I have to make sure the credentials read is idempotent. Remember, credentials never, ever, ever have update, delete, or create. They pretty much just all read, and read is equal to read and create. So make sure you code that idempotently. Otherwise, you'll have some weird behaviors. So the reason why I say this is that if role and if username is not defined, that's an indicator to me that the role has not issued creds, has not gotten the credentials yet. So then I have to reissue the credentials. So that's the kind of logic that you might need to include. I also include the response. In this case, I do return the token, even though it is sensitive, because you need the token. That's the whole reason why you're using Vault in the first place. You're using the token. And so in terms of anything else in here, I didn't remove any of the body of this. Most of this is returning information, but remember I mentioned before about retrieving the token from internal data. This is where it's important. It's going to be in the credentials interface. When you store the token, there's two sets of fields, which is you can store it into data or you can store it into internal data. Anything that you reference subsequently as part of a token revocation needs to be stored in internal data. So keep that in mind. Okay, you might think I'm done. I'm not. This actually won't work. The reason why it won't work is that, remember I mentioned you have to add the API endpoints to the backend. Well, these are still, well, empty. I need to add all of the API endpoints that I've created to the backend. So here's what I'm going to do. I'm just going to go in and add all of these extensions to the backend. Okay. And we're going to drop these in here. So there's a couple paths that we added, right? The role path, the config path, and the credentials. This is declared in a list because of the way that the interfaces are written for path config and path credentials. But make sure you add them, because if you do not add them, it will return an error that says unsupported path. So if you ever get an unsupported path, that is because that error stems from not having the path declared in backend. And the last thing that you'll want to do is add the token as a secret. All right. So with that, that's pretty much what it is to write the Vault plugin very, very quickly, because I know we're coming up on time. But very, very quickly, if you are interested in writing a Vault plugin and you do want to go into testing, there's 2 sets of tests. There's unit tests, which all of them are in here. They use a mock backend, and the acceptance tests. Acceptance tests are divided into 2 different types of tests, one of which is actually mocked in Docker. So there's actually a Docker environment that you can use to create a Docker container with Vault. And what that will do is update Vault with it's actually pretty cool. It's a Docker environment, and what it will do is it will update Vault with the plugin in place, and that way you can test the plugin and run the acceptance tests. I'll run the acceptance test really quickly, but what I'll do is I will drop the URL in the chat, and that way you can take a look at this yourself and walk through it as well. I'm going to also pull in this because you need the endpoint. One trick that I will say about the acceptance tests, do make sure that you have all of the endpoints accessible. Don't try to use this in a container. It doesn't work. I've tried that because it needs access to the endpoint. Also, I don't know why I have breakpoints, but that's fine. All right. So if you're interested in learning more, or you want to follow this code yourself, I'm going to drop the link in chat in Twitch and YouTube. You're more than welcome to reach out to me with any questions. This is not as complicated, but I know that some of the interfaces are not well documented. So if you ever have any confusion or any concern, you're always welcome to reach out to me. In addition to that, I hope that we get to fold this into a Learn tutorial officially, but I wanted to make sure to go through some of the important files and the important backends. If you compile this and build this yourself, you'll notice that the token for HashiCorps will revoke and renew accordingly. So thank you very much. And that concludes HashiTalks, I suppose.
Hey, guess what? I
What
got
happened?
bingo. I got bingo.
You got bingo?
Yeah.
Who got bingo? Oh, there we go.
We all did. You know
Oh,
what's
really? What
crazy
did
is we waited for so long, and all of a sudden you went create, read, update, delete list, and was like, done.
Wow. However that list generated, it was not very random, was it?
No, but it was great for our game. We really enjoyed it.
Instant gratification. Yeah. Thanks all for joining and playing bingo.